Tell me what that means. Sorry, number one.
Number one, I guess just try getting the highest.
Tell me any particular reason for that?
Nothing. I think I just wanna do good.
Is this one not very clear. Is science something like your the subject that you like or something like that?
Science is math and science is like both of my parents like subjects. They're pretty good at it.
Ah, right.
Just want to do good.
That's
Yeah.
I'm totally for you making your parents happy, right? Totally fine. But do you also like science and math? Just checking in that sense. Maybe don't hate. I don't know. What do you
It's
think about
I
those two
don't it's not
subjects?
like I like it, but I also don't hate it. It's
Mhm.
like it's neutral.
You don't hate it. It's fine, something like
Yeah.
that. Okay, sure thing. I can understand that. All right. Yeah. But I do notice that both your parents are, so to speak, the science people,
Yeah,
lah, right? I do know. I
because
do
my
notice that,
mom was
right?
like a chemist, if I'm not wrong.
Yeah. Good. I understand. When other forms of motivation appears in you, like you would notice that probably that maybe you yourself also like it more or whatever, or you do want to do well for whatever reason, feel free to tell me, right? If you're suffering in some sort of motivation, like you're demotivated, also feel free to tell me,
Yeah,
right? Okay. All right. Any other updates from school?
nothing. That's just
All
probably it.
right. Mm-hmm. I'm just fixing something. Okay, Ria, I'm kind of fixing it, so you can fix it now or later, okay? You can fix it now or later, right? Okay. But take your time. I'm not rushing you, yeah. I want you to understand this like from your heart, so to speak. Okay. So I take it, Jason, today we do have some sort of we can do whatever we want today.
Yeah,
Let's put it
pretty
right now.
much.
The class also isn't starting until, class isn't starting much. Is it correct?
Yeah.
All right. Okay. So no new, particularly new or topics or whatever lah at this point.
Yeah, pretty nothing.
Okay. Good. All right. Okay. Ba-dum, bum, bum. Hmm. Any of your any of your subjects are express level? I forgot to ask that actually.
Oh,
Some NA people take certain express, right?
uh, no, English and science is G3. Everything else is G2.
Sorry, correct me again. Sorry, what? The what and the what?
Uh, English and science.
English. Oh, your science is G3, right? Oh,
Yeah,
sorry. They call it G3 now. Your English is G3. Well,
yeah.
I'm quite happy to hear that. Good. I hope you like that. So G3 and G3. I see. Now I know. Now I know. Let me think carefully. What should we do today? Let me think. Yeah. Let me think. There is no point in talking about end of year. No point. No point right now. You still need to learn the algebra. Mm, there isn't really much point talking about science. Science, you can deal with it. Mm, for your school, there will be some sort of SA one, I guess, something like that, mid-year or something.
Yeah, I think so. That's before
All
like,
right.
I think, yeah, that's probably gonna be like before June.
Yeah, maybe mid-May. Usually second week of May lah. I mean, still a long time. No problem. Two months from now. Has your CCA been settled?
Yeah,
All right. So the CCA days are not gonna interrupt with our tuition. I'm just checking.
yeah, they won't.
Sure thing. Okay. Anything else that we need to confirm? No. No. Okay, cool. Now, would you say in your math exam, you experience certain some kind of pressure, lah, so to speak, because you say that, oh no, you're the relaxed type, right? So I can kind of feel that. Just want to check lah. Did something like that happen in the exam?
Not really.
Mm-hmm.
Yeah, it was all right. I didn't really think
Mm-hmm.
of much. I was just focusing on the exam.
Mm-hmm. Mm-hmm.
That's
Mm-hmm.
and
Mm-hmm.
I don't know. It doesn't feel like I'm rushing, but it looks like I'm rushing because I finish it in like very early.
Mm-hmm. Well, a calm person might actually finish faster than the rushing person. That might be true, especially when the questions are not easy or simple. The calm person might actually finish faster and will definitely do better than the rushing person. I mean, rushing only works when things are very easy, easy to
Yeah.
very easy. Not the most useful technique in exam to rush. Okay? Okay, later you cannot think, right? So, glad to hear that you don't have a time problem. That's basically what you're saying. No? That's
Yeah.
great. That's no problem. That's great. Okay. Hmm. Yeah, I'm fixing Ria's. Ria, would that be okay?
Yeah, wait, so the third equation is when the NaCl is diluted, so the H plus and OH minus reacts first.
Again, the H plus will happen no matter what. The H plus will win no matter what, whether concentrate or dilute. So let's clear that misunderstanding first. Okay. The Na plus H plus competition is not decided by the concentration or diluting. It's not. Okay. H plus always wins. The question of dilute or concentrated is to determine who wins between Cl minus and OH minus. Will this be okay? Am I making any sense?
How does the concentration affect it?
Right. So one more time. One more time. So NaCl concentrated, just imagine that therefore there is a lot of salt in the water, right? A lot of Na plus, a lot of Cl minus in comparison, comparatively fewer water molecules, like, concentrated. Make sense? Or not? Am I making any sense? That's concentrated, concentrated Milo. You have a lot of Milo inside a cup of water.
Yeah.
The Milo is a lot. Okay. So since the Cl minus is comparatively a lot, Cl minus will win from OH minus because OH minus comes from water. You have more Cl minus kind of compared to OH minus, which is less if it is concentrated. You flip the scenario into dilute. Dilute simply means a dilute Milo doesn't taste nice at all. You have less Milo, more water. So more OH minus, less Cl minus. So OH minus wins because of there is more water. It's just there's more. That's all.
Wait, when you say win, do you mean it just reacts first, or that's
The real thing that happened is basically like Cl minus OH minus fighting for the event. So the one which is managed to crowd it more, crowd the graphite more, kind of steals the electron first. That's basically what happened, basically. So
okay?
whoever is more numerous kind of wins in that sense. If that can be, that's basically what happened. Basically. They won't tell you to describe that though, but they need you to know that. Something like
Okay.
Okay, clear, yeah? Okay, good. Very good. Now, Jason, sorry, yeah. Okay, because a little bit unexpected today. Just a minute, yeah. So give me one more minute. Okay. Okay. Now, I'm going to give you two scenarios, which is exactly in principle, exactly like what we described, the basic scenario and the equal scenario. So I'm gonna, for example, give you the scenario here is PbBr2 liquid. The next page for you. And then here, I will give you another scenario, CuSO4 aqueous. There you go. Okay, so I'm asking you to determine the reaction in these two situations in page 7. Could you do that? Yeah. There is nothing new here in principle. You're supposed to think about the basic scenario and the aqueous scenario. Okay, Ria? Okay, so I'm waiting for the two reactions, but do the full analysis. Okay, good. Now I'll mess you up a bit, Ria, and I'm gonna ask you to revert the battery. Okay, I'm messing you up a bit. Okay. Okay, because the exam is done. Okay, so back to you, Jason. Since we are kind of free, right?
Yeah.
Okay. Your camera is a bit too zoom in. Let's zoom out a little bit. Me. Okay, nice. Okay. We are going to do some. Okay. No. I know. I'm going to do. Okay. No. Do. Okay, I'm gonna share screen with you. Okay, got it. Okay. I'm gonna share screen with you, Jason, just to show you something. Share screen. Ria, you feel free to ignore the screen sharing. So this is secondary 1 express. True express means G3. Jason, but
Yep.
ACS Barker is a little bit on the easier side. So
Oh.
you should not assume this to be something that is harder than your standard. So
Okay.
ACS Barker, right? So 1 hour 15, paper 1, whatever. There's going to be paper 2 that depends on the question itself. You just see question 1 and question 2. You know that question 1, question 2 is what you have been learning, if that makes sense. Okay, so no surprises there. But you look at question 3 and question 4, you suddenly have basic algebra. Okay,
Yeah.
right? Okay. Okay, so we can practice that later. And then suddenly in question 5 and question 6, you are expected, you know how to do this already.
Yeah.
Okay, that's part of exam, right? So nothing surprising to you. I just want to show you that. And then in question 7, this is more like something that you will learn in term 3, I think. But question 7 is really a repetition of what you learned in primary school.
Yep.
There isn't really much, okay? Nothing complicated, nothing difficult. Just want to show you that, right? Then in question 8, you have a sort of 3-mark algebra kind of thing,
Yep.
kind of, right? Something like that. Okay, and then there's a percentage question. Percentage question also coming from primary school, coming from there, right? Okay. Just continuing. Oh, there's a conversion from kilometer per hour to minute. Also primary school. Can you see that? Okay. Primary school. Question 11, ratio, also primary school, right? Not easy, but definitely not hard. Okay. Hey, look, circle and square, primary school. Same thing, isn't it? Still the same thing. Still the same.
Yep.
Okay, and a little bit of actually 13A looks complicated, but it's very easy. Can never mind that for now. Construction, never mind for now. That's new. Sort of angle thingy. I would think that this is something you do in primary school, right? I would think so. Okay, Ria, I think you still have that. You still don't have that. Yeah, it's like BR cannot exist by itself. Okay, I want to show you something else. Oh, okay. So Jason, they can put this in paper 1. They can put this in paper 2. Look at that prime factors and everything, right? So okay, very, very expected, right? Okay, looking good. Good. Okay. Yeah, Ria, you gotta write down the full just for practice. this, very easy. The graph, I'll skip for a while. Patterns. Patterns is definitely from primary school. Some people like it, some people don't like it. Look at that. Patterns. Then, angles again. They really like angles, right? And then some sort of new thing, maybe trapezium, I don't know, but this is like a prism. They call it a prism. Maybe something new to you. Not difficult at all, I can tell you, if you learn properly. Not difficult, but they usually learn this in term 3 lah, right? Just saying. And there's one. Look at that. There's a speed question, no? Train A travel here, train B travel here, time B. Hey, partly primary school, the part C, an equation, its x is more like a secondary one. So this is like the hardest algebra question they will give you. They really like this kind of word problem algebra, right? So this is something that will be the final goal of your algebra learning in secondary one. This usually happens around end of term 2 or starting of term 3 lah, something like that. So maybe in SA1, maybe not, depending on your speed lah. Speed. And then some sort of conversion from money, that's a bit new, right? Okay, percentage. And they still have this. Okay, I'm gonna ignore that for now. They have this. I'm gonna explain that later. Okay, so like that. So I'm just curious, Jason, mainly from your primary school experience, do you have particular topic that you feel that, I want to try a little bit because maybe back then you weren't so sure?
Nothing much, but I think I just forgot how to do them. Some of them.
You mean
But
the angles, you just have to get.
Probably like
Sorry, you're saying?
conversion speed and patterns. Those are the things that I really didn't like on primary school.
Yeah, I can definitely sense that. You can sense that. Okay, so I just want to know that a bit because I can tell you that this will come up again sooner or later, and sometimes by surprise. Sometimes. Oh, Ria. Oh, Ria. Your charge is a bit of a concern, isn't it? Definitely. All right. So sometimes by surprise, because sometimes your teacher kind of just assume that we discuss about it, there's nothing new, so you just practice yourself, something like that. We have a lot of time. We can kind of clear that first, especially pattern, because pattern turns out to be kind of like the big surprise. I guess they kind of just reappear again, something like that, right? With some algebra. So I'm just gonna screenshot a few, right, for you. Let me see. Yeah, I'm gonna do that, and then you're gonna. Okay, there you go. Okay, so I'm starting to put them in Jamboard already, Jason. So you can go there and start to do it. In page 17, I believe I'm putting it there. So I'm stopping my screen sharing. Easier to. Even though this school is easier than most, they do manage to sneak in some tricky question. So Jason, you're supposed to go to page 17. Yeah.
Yep.
Oh yeah, you're almost done. Okay, so Ria, remember in the equals one, you get used to the fact that you have to consider concentrated or dilute. By right, the question will tell you which one. Okay, so I take it that this is the concentrated one. You gotta do the dilute one, please, and then figure out the two. All right, that'll be okay.
How do you get the total with diluted?
First, you gotta work out the dilute who wins first. Because frankly speaking, you didn't focus on the competition at all. In the aqueous side, you have competition. You're so confident that Cu plus will win that you don't consider the competition at all. That is the issue. You don't get the principle. The principle is there will be competition and you gotta determine the winner. Check one more time your Cu2 plus, the competitor first. Also, SO4 2 minus will have a competitor, and there is the answer to the dilute situation. If you don't understand, please tell me, yeah? Right? Or look at the previous gem. Okay, good, good. Now, how do you determine the winner for Cu2 plus and H plus, right? Again, you can check the Jamboard.
Is it the reactivity thing?
Correct, correct. The one who needs to jump up less, right, will win, so to speak. Jason, are you okay? Jason, are you okay?
Yeah. Wait. What do I do if there's like two different letters in one
Yeah.
thing?
So the principle is surprisingly very simple. The principle is in a plus minus relationship. This is a plus minus relationship. Make sense? Plus minus. In a plus minus, different letters don't mix. It's as simple as that. X should just go with other X's. Y should just go with other Y's. And they are sometimes naked numbers. Here don't have, yeah, but sometimes they are just pure numbers. Pure numbers also don't mix. Again, in a plus minus relationship, X don't mix with Y don't mix with pure number don't mix with X at all. You just combine those which are of the same letter. Does that make some sense?
Yeah.
All right. Okay, so you do you. See what you can do.
Okay.
Of course, feel free to skip first, yeah? Okay,
Yeah.
so there's multiple topics here, okay? So Ria, tell me, are you stuck somehow?
But wouldn't copper win?
Correct. No, you're absolutely correct. Copper will win because according to the reactivity series, copper jump up, right? Remember, copper do jump up is smaller or shorter than H jump up. So congratulations, well, I'm assuming that you accidentally chose the correct winner. Why do I say accident? Because you didn't consider the competition at all. In that sense. Okay, you should consider the competition just to make sure, and you have now made sure that yes, U2 plus wins. I agree with you. Would that be okay?
Mhm.
Okay,
How do you
so
get
plus
the thing for dilute?
again, dilute means consider the competition, right? The competition is between SO4 2 minus and OH minus, correct? So when it is dilute, who is more, the water or the SO4 2 minus?
No water.
Then the water means. Yeah, it's okay, Jason. Don't wait for me. You continue the rest. Yeah. Yeah, I'm just copying your working.
Philip, for question 4, how do I do it? Because
All right.
I don't know how to do it.
Right. The word factorize is very common, so to speak.
Yeah.
Priya, I agree that OH minus wins, but refer to the weird reaction. Okay, I ask you to memorize this one.
Oh.
The weird reaction from yeah. Okay, good. So, Jason, I'm gonna write something, no explanation, right? That's
Okay.
normal, right? I show you something, you kind of figure it out and kind of we do it together. One thing for sure though, factorization is very important. So
Mm.
watch what I'm doing. Oh, okay. I spot an A with 2. So I do that. I can do this, right? So far, so good. That's my first factorization. I'm basically taking the A out, right? And then I spot something interesting between 7 and 21. And so I commence my second factorization.
Mm-hmm.
And then I say, I think I need to stop. I think I'm happy with this because nothing else can be done.
Uh-huh.
Okay, so yeah, I have just factorized, so to speak. This is what they say lah. I have just factorized A and 7 out. I have just done that. And they are quite happy if I do this for them. Okay, let me put it in another way. Factorization is like the total reverse of, well, expansion, right, so to speak. So I can actually do the reverse, right? If I reverse everything, I will just do a rainbow twice, correct?
Mm-hmm.
Do a rainbow. I will end up with 7A minus 21A, I'm sorry, AY, something like that, which is back to the original, What does that mean? Factorization is just the reverse of rainbowing or expanding. Okay?
Mm-hmm.
Is this enough? If it is enough, erase it and do it yourself. Ria, I think your dilute reaction is correct. Are you okay so far?
Yeah.
But what is the total? The total should be different. Correct? So your number 1 is the same, correct? So you gotta combine your number 1 with your number 2. Remember one thing, when you combine, the electron must be the same. Why is this important? Because electron go in must be the same as electron go out. Now you would notice that this one is 4 electron and this one is 2 electrons. So you got a times 2 everything wonderful. All right, then that will take care of the problem. Okay, Jason, whenever you're ready, you erase my working and then you redo. Okay, Jason, I am a little bit worried. You're making mistake again. This is your double minus and that is wrong. A little bit worried, there.
Okay.
Remember your double sign thingy. Okay, no matter how relaxed you are, I do expect that you can kind of spot that. Okay, so let's see. The 2 is fine. So I'm going to check the total. This is great. Oh, sorry. Okay, this is great. I like it a lot. This is great. This can cancel each other, which is great. This is, oh, that's fine. That's fine. This 2Cu is great. 2H2. Right, cool. Cool. It's great. Okay. I have a special comment here. I'll keep it later for later. Now back to your easier one first, right? This is great. This is great. So I'm very confused about this. Very confused. Yeah, this is correct and this is correct. How come this is wrong?
Oh.
Okay, good, Jason. Okay, then I'm gonna erase my working first, Jason, yeah? Right?
Yep. Garfield, how do you get 3 and 1?
3 and 1. Okay, now you have factorized A, right? You have factorized A, so that's good, right? So how do I get, that's not the problem. That's not what I'm thinking. I don't think about 1 and 3. I'm thinking about, is there anything else common between 7 and 21? Why? The one thing I notice which is common is the number 7, because 21 contains 7. Right? 21 contains 7. So that's what I do. I just take out the 7 and I will have something remaining. That's your answer to 1 and 3. So you may want to take out the 7 and let's see what is left behind. Now, Ria, everything is okay so far. I am very confused with your charge, but other than that, everything seems okay. Okay. The charge one seems to be the same problem from back then when we do trial, right? You're still not, you're still not confident with the charge at all. Oh. Never mind. The rest is good. The rest is good. I like the rest. Okay. Now, Ria, I'm going to tell you one new thing, okay? I'm going to tell you one new thing. SO4 2 minus, okay? SO4 2 minus, this is what they call a complex ion. It's called a complex ion because it's made up of more than two, I guess one or two. This is quite complex, as in complicated. Okay, Ria, this is a complex ion. A complex ion, here's the rule that happens in real life. It never wins. Never, 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 never wins. So in a competition between SO4 2 minus and OH minus, the SO2 minus basically just withdraw from the competition and will not do anything at all. There is a good reason for that. They don't ask you to explain that. You just have to remember that they never wins. So instead, not to confuse you, OH minus here wins by default, just by default. All right, and then the total will be different, but you don't have to worry about it. I'm just telling you something new.
Okay.
This is what happens in aqueous situation. There are a few complications. Would that be okay?
Yeah.
All right.
Wait, is it okay
Now
if we do,
yes.
if
Yes.
we do another question?
Of course. In fact, you are going to make your own question now. You're going to make the two scenarios, the liquid scenario and the aqueous scenario. You are going to make them. Okay? This is boosting your confidence. Okay, make your own question. In page 8, I'm going to watch the question before you do that. Okay. Jason, you're very stuck, is it, Jason?
Yeah,
Okay. Okay, Jason. No. First thing first, Jason. First thing first, let's go back to page 3 first. Page 3, your double minus is the problem right now. Gotta fix that, please. You're supposed to be able to do this, right? Okay, again, for y, minus belongs to 13y and minus 5x both. So for y becomes minus 13y, which is totally great. This is fine. This is fine. This is a minus 5x, which it should becomes a plus. There's a double minus for the 5x.
Oh,
I expect you to know this because this is part of exam. Sorry, was this part of exam? Isn't this part of exam?
it wasn't in my exam. My
It
exam was,
wasn't in your exam.
yeah,
It
my exam
wasn't.
was pretty simple. It was only like chapter 1 and chapter 2. We didn't have any algebra inside.
Yeah. I really want you to. Therefore, I really want you. You're still forgetting or still not somehow not internalizing the double minus. Okay, am I making any sense?
Yeah.
All right. So you fix that in your working. I want to see.
Okay.
Okay. Again, I teach you to declare to yourself that this is double minus. Do not think directly. Just by double minus. That's the most important thing that you realize, and then you plus it just like that. Yeah. I want you to do that to remind you that you need to watch double minus. Okay, good. So fix the second line. Thank you very much. And then you are, and 4y minus 13y is also not 9y. Come on. 4y minus 13 is not 9y.
Oh,
Come on. Right. You still have minus problem. All right. So be careful. Okay, good. Okay. So Ria, are you having trouble finding, making a question? Right. So making a question means that you kind of understand how to set up the whole thing. So to set up the whole thing, you just require an electrolyte. I want you to choose an electrolyte for the first one. Choose any random one. If you have trouble choosing, that is in the sense what you need to learn. You need to be able to be comfortable with electrolytes. Now, please try to write an electrolyte for the left one. Okay, Jason. So my intention is to take out the 7. That is the one I'm thinking of. Yeah, that's my intention.
take out the what?
Now, take out the 7.
Okay.
Because there is 7 in 7 and there's 7 in 21. right? So that's my intention. I just write 7a lah. I'm quite confident with that. Okay, now what the question is what remains lah, right? So the minus 21y, that's the easier one actually. Minus 21y, what remains when you take out 7?
What does that mean?
HCl is fine, Ria, but HCl is fine, isn't it? But the issue with HCl is that it's aqueous, Ria. So I don't mind, but you're gonna take this as the aqueous scenario lah. Because there is no HCl pure. Okay, Ria? You feel free to choose this. No problem, I like it. Now I want a pure electrolyte, which is not aqueous lah, right? Choose something for the other guy. Again, Jason, when I take 7 out, right, I'm left with minus 3y here. Does this make any sense?
Kind of.
And to use the same principle, when I take out 7 from 7, I'm not left with 0. That's wrong.
One.
I'm left with 1.
Yeah.
Right. It's not 0 because it's 7 times 1, right? It's 20, it's 7 times 3 and 7 times 1. So I'm left with that.
Okay.
Right? I'm going to erase that again. Okay, give it a try. Your first factorization, totally fine. Now, Ria, do you have trouble quoting something which is not equals? Okay, then quote for me an ionic substance. You have to understand that electrolytes are always ionic. That's great, Jason. That's totally fine.
Okay.
Your first factorization, we're going to practice more next time. Don't worry about that.
Yeah.
Right? Okay. It's just a survey for you, right? Again, Ria, something ionic quote for me, please.
Sodium carbonate.
Sodium carbonate is definitely ionic. Okay, I'm gonna write down first sodium carbonate. And then I'm gonna tell you the problem with sodium carbonate. The problem is not you, right? No. Sodium carbonate, you will learn maybe later. I don't know whether you've learned this or not. This is supposed to be in the reactivity series. You're supposed to learn that sodium carbonate is just solid. It cannot be liquefied, which is a problem in electrolysis. You need a kind of liquefied ionic substance. Okay, so Na2CO3 is a fine ionic substance, but since we cannot liquefy it, choose something else, please. Okay, give me more. It's okay. Generate random stuff.
Magnesium sulfate.
Magnesium sulfate is definitely can magnesium sulfate be liquefied? I have no idea. Actually, I have no idea. Oh. Okay, I tell you what. Give me because this is the positive side, this is the negative side. I want you to give the negative side, which is not complex, something simpler, so to speak. Would that be okay? Maybe it's called magnesium something else.
Chloride.
Chloride, it's good. Now, what's the chemical formula of magnesium chloride? Looking good, Jason.
MgCl2.
And you will be correct. Okay, there. This is liquid, okay? Liquid, not aqueous. And you have created your own question. You have. It is that simple. In our two scenario, the electrolyte is the one that determines what will happen. That's the variation, and that's what we need to think about. Do you understand?
Yeah.
Let's see. This is the knowledge you get by setting up your own question. Hopefully that helps. Please run. Okay, looking good, Jason. I think you're doing good stuff. And as per usual, Jason, I think you managed to disregard the negative again. The double sign hits you again. The times 4 and times 3 is wonderfully done, but the double sign manages to hit you again. You're kind of just ignoring it.
This one.
Yeah, so this minus belongs to who? Belongs to the 6, is that 6?
Yes,
6, right?
6, yeah.
6x. Does it also belong to 3y or not?
Uh,
I mean, it's minus 2x plus y over 4, right? Minus the whole thing, correct or not?
mhm.
So I think logically, minus is affecting the 2x and also the y, if that makes sense.
Mm,
Tell me if you have trouble accepting this.
not really, but just a bit
Oh,
confused. I don't know, like when there's a double sign, because it's fractions and it's a bit weird.
Let me try that. I want to talk about it. I want to talk about it. These are all the principles that you need to know. Best if we talk about it rather than.
Yeah.
So the issue is right now 2x plus y over 4 minus that, correct?
Mm,
Okay. Just to be clear, the minus is the minus everything, right? So, to
mhm,
speak. So take it this way. If you think that the 2x is minus, it must be because of this negative. This negative is the one causing the 2x to be minus,
mhm.
correct? So if the minus is causing 2x to be minus 2x, the minus is also causing the y also lah. Because you know we're minusing 2x plus y.
Mhm.
Think about it that way. I guess the minus is affecting everybody. So minus 2x, also minus y.
Okay, but at the same time,
Yeah.
uh, how is this minus belong to this one? Because usually minus is just like there would be like another minus to show that it belongs to like this one.
Like how does minus belong to y is what your question.
No, how does like the minus belong to the 2x plus y over 4?
Okay.
Because
Okay.
usually if it's like uh it belongs to it, there'll be like another minus no or to like show it.
Okay. Let me try. Mm, okay. Let me change my words. The minus affects 2x plus 1.
Mm-hmm.
Belongs or not belong, it totally affects. Because we are minusing 2x plus 1
Mm,
together. So whether fraction or no fraction, the minus is minus 2x plus 1. So for example, yeah. Let's pretend that there are no letters here. Yes, let's pretend that there are no letters. So 7, right? 7 minus bracket, okay, 2 plus 3. Okay, for example. So whether minus belongs or not to 2 plus 3, minus is affecting 2 plus 3 together. Which is to say 7 is minus 5, correct?
mm-hmm.
Now 7 minus 5, isn't it the same as, think of it as 7 minus 2 minus 3? Isn't it the same?
Yeah.
So minus is affecting both 2 and 3.
Mm,
Okay, let me give you another example. 7 minus 2 minus 3. I can do that also, right?
yep.
Minus is affecting 2 minus 3. Okay, so you can think of it as 7 minus 1. Can? Make sense?
Mm-hmm. Yep.
You can think of it. You can also think of it as 7 minus 2 minus 3, which is a double sign plus lah, which will again give you the same answer as the 7 minus 1. Am I confusing you or is this okay?
It's all right, I guess.
Okay. Did I answer your question? That's a very important thing, you see.
Yeah.
Okay, cool. Right. Then try to correct your mistake. Let's see what happens.
Sure.
Again, Ria, you're forgetting the principle of who wins in the competition between CL minus and OH minus. If you declare OH minus wins, what is the reason? What is the reason that OH minus wins? I have to write down the reason for you every time. Now, what's the principle? How do you choose the winner? Don't erase your working. I'm asking you how to choose the winner. Yes?
The smallest jump.
Yep. That's for the reactivity series, which covers the +1. So it's a little bit weird that the -1 doesn't present to you any sort of reactivity series. But to be fair, in your current reactivity series, you don't see any Cl and you don't see any OH, correct?
Mm-hmm.
And we haven't been using any, negative ion reactivity series for the past two questions also. Correct? Look at the previous page. Like, how do we determine the, look at the first page, the page six, right? Page six. Okay, in page 6, there is a competition between Cl minus and OH minus. Now, who wins? It is not determined by reactivity series. That's the weird thing here. But it is determined by something that I hope that you will remember.
Mm-hmm.
There. Concentration and dilute. Concentrated and dilute. Who crowd first? Who is more crowded, so to speak? Back to your current question, if you declare that OH minus wins, I'm okay, but please tell me the reason. Why is OH minus winning? Because it's dilute. Thank you very much. That's it. That's all. In a sense, it's much simpler than reactivity series reason. I mean, it's confusing, but it's also simpler. So I guess we call it a memorization for now.
Mm-hmm.
Okay, so okay, I want to clarify one thing, Jason. Just to clarify, in your work, right? Okay, this is still plus or what? What is that? Is that a plus or a minus?
Minus.
No, that's still a plus.
Oh, yeah, that one.
No, that one is still a
Eh?
plus. It's inside, ma. The original one is 2x plus y. So this is
Oh,
plus
yeah.
Minus affecting it doesn't mean that it changes at that point. Is this a plus or minus?
At that point, I don't even know.
That's a plus also. That's a
Okay.
plus also. So the way you do it is, okay, I'm gonna just make some space. Okay, the way you do this is, so 12, when you combine everything, 12x,
Mm-hmm.
20x, minus 6x, correct? The minus is fine, right? Minus 6x. And then minus 3y. I'm sorry, minus plus 3y, correct? Minus plus 3y. Which is to say it is a minus lah.
Mm.
Does that make some sense?
Kind of, I guess.
So that's how you present lah. Don't change the positive here into negative, because it looks like you're just changing the question. You change it when you finally, so to speak, open it up, so to speak. You change it at this point, if you want to. This sounds totally new to you. Let me check. Because
Yeah.
it doesn't feel new. Oh, wow. I thought you have learned this. Now, I'm pretty sure you have learned this. You have been learning this lah. But I take it that this is still confusing. Never
Yeah.
mind. Today, we are just browsing through this. I want you to look at other topics anyway. That's my goal today. So good to know that you're still struggling here. Exam is not coming. We'll take care of it from now on. Okay? If you feel that you're a bit worried about this one, well, you should be, but I want to do a topic survey today. Right. So follow me for now. Please do question 9 and everything. Right.
Okay.
Okay, Ria. You are okay. You're waiting for me. I don't mind you waiting for me, but I want a full description of the reaction. Right. Okay. Full for both lah.
Full description is
The full reaction. Right. The full reaction.
Oh.
The full reaction. Right. The full reaction. Full for dilute and then full for concentrated because we're a different winner, right? Looks great to me. Looks great. That's fine. So, okay. Okay, that's the value one. Sure. Okay, now tell me, Ria, why is your first total not correct? No, sorry, no, Ria, don't write the minus 4e and the plus 4e. That's not what I mean. The minus 4e is there, but because the chemistry don't like it, you kind of move it to here as plus 4e, correct? Correct enough. You don't get to write both. You don't get to write minus 4e here and then plus 4e here. Tell me if you're confused. Jason, are you stuck with question 9? Sorry.
Yeah, because with percentage, usually there would be like a number.
You are absolutely correct. You're absolutely
Yeah.
correct. Now, to help you think, why don't you just invent a number? That's totally fine. Just to help you think.
Okay.
Right? Okay. Okay, so Ria, for the full concentrated one, since you have the 2e, this is a very good sign. You can kind of cancel this up. The electron goes in equals to electron goes out. This is like great. This is balance and everything. Okay, for the full reaction concentrated. Now, I'm saying this because you still make the same mistake in the full dilute. In the full dilute, you make a mistake regarding the electron. Could you please find out what it is?
For the dilute one.
For the dilute one. The concentrating one, great. Jason, have you invented a value? Tell me
100.
a value. 100,000, you mean?
Yeah, 100,000.
Okay, sounds about right for a price of a house. So 100K. Okay, so good. Okay, then you use that number
Okay.
to think. Okay, wonderful. Yeah, you're now making 4E. Now, once you have 4E and 2H2, yeah, okay, great. Then as a final formalization, you kind of cancel the 4E. They do expect you to do this. Okay, this is a sign that electron in is the same as electron out. Now, Ria, what is your mind doing here? Are you trying to memorize everything?
No.
Are you trying to understand it, so to speak?
Got feel it.
Yes.
I don't remember how to do percentage
Right.
from
Looks like we do
6.
have a lot of cover. Yeah, we do have a lot of cover.
Yeah.
So we cannot keep discussing everything. I want you to look at question 10, question 12, question 3. Is there anything that you can do first? Okay. I understand you're skipping it. This feels hard, but it's not exam, just a survey. Look at the other question first while waiting. Now, yeah, you're not trying to memorize. I like that. Are you trying to understand it in that sense?
Yeah.
Very good. Then whatever mistake you make, I don't mind. If you try to memorize, your result won't be that good one, even if you get it right. But if you're trying to understand this and still making a lot of mistake along the way, that is very understandable. This is supposed to be the hardest chapter anyway, the most complicated chapter, a lot of things to consider, right? What I mind though is when you try to understand is that you don't ask questions, or rather you don't try to figure out what's wrong. Every time I point it out, you kind of Don't ask a question. So I'm a bit concerned because it feels like you're memorizing it instead of trying to understand. Now, if you are trying to understand it and my correction is now, that's fine. Again, I don't mind the mistakes. What I mind is that you don't think about it, so to speak. Okay, yeah? And yeah?
Yeah.
So keep the questions coming. I already like what you're asking, but keep your questions coming. Do you want more practice? We are ahead of class. We are not catching up in any way. If you want more practice, that is time well spent. Do you want more?
Yeah.
Then go to the next page and make another one. Another two scenarios, one liquid, one aqueous. I'll do a check with you. Believe it or not, this is helping you with your previous chapters also, right? This is forcing you to do something good. The one I can guarantee, right? So follow me, even though it doesn't feel very good. Okay, so Jason, you decided to do question 12. I guess that makes sense. Why is it 154 times 4, Jason? Why is it times 4? Ria, are you okay?
Yeah.
Have you chosen your, okay, you can drop. Okay, good. Right. Jason, tell me, why is it times 4?
It's because I simplified it into 4 circles.
Now, tell me, how come there are 4 circles?
Uh, there's like 2 semicircles, and then it just becomes 1 circle, and then the other 2,
Sure.
and
Mhm.
the quadrants. I just
Again, count
combine them.
again. Are you sure there are 4 circles? Count again.
I think so.
Right? I'm gonna count with you, okay? I count with you. Okay, good, Ria. Choose the electrolyte phase. This is how you make your own question, right? Choose your electrolyte. So here's 1 circle. Would that be okay? That's 1.
Yeah.
Here's 2, which is great, right? Easy. Okay, so where is number 3? 3, right?
Yeah.
Now, is that number 3?
Oh.
Is that number 3 circle? No, right?
No. Yeah.
No, that's number 3. Right? Be careful.
Yeah.
Yeah, be careful. Right, okay, good. NOH, good, Ria. Now, will this be the aqueous one or the pure one?
Pure.
Okay, I think. Whoa, is that NOH liquid? I have no idea. Okay, never mind. Okay, I'll just make it. I'll just pretend that it does first. I just pretend. Okay, yeah, my knowledge is not that good also, right? So I'm not sure, but let's make it pure NOH liquid, right? Who knows? It's possible. In fact, it might be possible. Okay, good. Decide another guy for aqueous, right? In fact, sodium carbonate. Sodium carbonate seems fine. Sodium carbonate seems fine. Yeah, try the other guy, sodium carbonate aqueous. Just now back then you wanted sodium carbonate. I say cannot be in pure form, but definitely possible in aqueous form. Definitely possible. Okay, so Jason, that's 3 circle. Now, what else can you do?
Find the small square. I think.
Yeah, I agree. I agree. So how do you find the area of the small square? You need the sides, right?
Which 7 times 2. The only thing I really don't understand is the percentage part. I guess.
I agree that the percentage will be,
It's
a bit unsettling, but
quite
in this
annoying.
case, doing the real number first is gonna be helpful. So let's do that first before we talk about the percentage. Okay, it will make it very easy. Yeah, I promise you that.
Mhm.
Okay, Ria, I know that you want the reactivity series. Okay, good, very good. Make sure that you list down the competitors. Electron flow is great. Now you list down the competitor and then you decide who wins, right? Okay, I agree with you, Jason. The area of the circles and the area of the square is there already, right?
Yep.
Now, he wants shaded, unshaded. So I take it that you have managed to do the unshaded one, correct? All
Yeah.
the white ones. You have done that. So how about the shaded part? Is it possible for you to calculate the area of the shaded part? Never mind the percentage for now.
Yeah, I think so.
Okay. Okay, Ria. So for the OH1, I did request you to memorize. So that is one of the few rarer times where I ask you to memorize. Be careful of this reaction. This reaction is not done like this. It's done in another way. This one I am asking you to memorize because it doesn't make a lot of sense. Fair enough. Please memorize or take a look at the previous gem. Okay, so Jason, you decided 7 plus 14 plus 7 looks good to me. All right, okay, makes sense, makes sense. Ria, the OH minus reaction is wrong. Look at the previous Jamboard.
Oh.
Okay, so Jason, you got the full one, right? The full square, and then you have this one. So, can you find the shaded part now? Okay, looking good, Ria. Now, okay, good, okay, good. All right, that's the plus 40, right? Okay. Okay, you got some.
That's the unshaded part.
Uh,
1
sorry,
to
sorry.
6.
Why is it 3? Oh, it is. No, that makes sense. That makes sense. Okay, good. So 1 to 6, that's unshaded. So
Yeah.
now I promise you that all these numbers will be useful, right? So now find the area of the shaded part as a percentage of the unshaded part. You know what? Sometimes we think of percent as just fraction. In the end, percent is just fraction. So if I replace the word, okay, good. If I replace the word percentage as fraction, will it make it easier for you?
Right.
The area of the shaded part as a fraction of the
Probably.
unshaded. Okay, then what would you do? Okay, Ria, I can see that you're doing it very well. Wonderful. Okay. Formalization purpose, please cancel the 4 electron. It's a formality lah. You got a sub like that. This one is not here at all. This one should be erased. This one should be cancelled. Formalities. Is that okay, Ria?
Yeah.
All right. Okay, the rest is good, man. The rest is good. Okay, just missing some state symbol, but we can make do with that for now. Okay, looks good to me. All right, great. Okay, good. Okay, 1, 2, 6. This is the shaded over the unshaded, which is 7. Why is the unshaded? Why is the unshaded 7, 6?
Oh yeah, that's the full square.
Yeah. Mhm. Ria, the first scenario good already. Second scenario. Okay, come on, Jason. Come on. Ria, are you okay? Do you need some time to make note for yourself? All right, okay, cool. Okay. Remember what I teach you? You gotta think about the competitor. So list down the competitors. Okay, good. Then determine who wins. Okay, good. Now, Jason, this is almost done. So 126 over 658 is the second final step. The final step is just you press the calculator. Go ahead and press the calculator. Okay, it'll be an ugly number.
Mhm.
Okay, and then you show me what is in your calculator.
Decimal or fraction?
For percentage purposes, now what do you think? For percentage
Fraction.
purposes, no. Surprisingly, it's gonna be the decimal. You press the decimal. You press the decimal. Okay, this fancy number I cannot read, but that will be times 100%. Okay, what is that? 19. Okay, so that will be 19.1%.
19 point.
Does that make sense? This 0.19 blah 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 is immediately 19.1%. Does that make
Oh,
any sense?
not really, in my opinion. Not really.
Okay. So I'm gonna explain that. So obviously you are not comfortable with percent at all in a way that maybe it feels very complicated. It is not
Yeah.
complicated at all. So 126 over 658. I'm telling you that it is definitely 0.191 something something something, which is I'm telling you that's 19.1%, right? Okay. Now let me ask you to do something with your calculator. AC it first. Okay, so now 20%. Would you please type 20% in your calculator somehow lah, 20, and then there's a percent sign. Okay, good. Press equal or something. Now it's 1 over 5, which if you decimal it, SD is 0.2. Let me put it another way. That's 0.20. 0.20 is 20%. Proven to you, yeah? Okay, now I want you to type 19.1%. And then you equate it, and then of course you SD, yeah, SD decimal 0.191. There you go. Okay. Now, let me test you. So why don't you press another number, maybe 1.2, let's say 1.2%. Before you press the equal sign, I want you to predict what will the decimal be.
Uh, mm, 0.
Right. Yeah. Okay, good, Ria. Now this is great, right? This is, oh, sorry. I like that. Okay, I really like this. Right. Okay, so now Ria, good news or bad news depending on you. Yeah. So when you think about the concert, you're finally thinking about the concentration one. This one I really like. That's good news. Okay. It's just that you forget another principle that complex ion never wins. Complicated, yeah, I know. But you must understand that you're already thinking about almost all the right things. This is like the first time I'm very happy with your thinking. It's just that you forget something. That's okay lah. I mean, complex ion never win doesn't make a lot of sense. It's more like a memorization. Okay, most people like it because it simplifies things. Okay, if you're thinking about it, it does complicate things a little bit, but that's why we're training all this. So for the concentrated one, it turns out that the solution, the reaction is also OH minus because CO3 2 minus will withdraw from the competition. So this will be full dilute and full concentration. That will be the same. Will that be okay, Ria?
Yeah.
Okay. Do you need more practice?
Mm.
One
Is
more
there
if you
anything
want.
else to do?
Oh, there's the third scenario, the most complicated one. Yeah. There will be 3 competitors and 4. There will be 4 or 3 competitors. Be warned. You gotta get this one first lah. That's the most complicated one, and you gotta be able to handle that also.
I think another example because there's no time.
I'm sorry, you're saying?
I think another example because there's not a lot of time.
And that's fine. And that is totally fine. Okay? Please make another question, please. Right? You're gonna need all this anyway. So getting it right is good. It's good. That's why we do things ahead of class. Okay, so Jason, percentage, right? So have you decided on your, right? Okay, if you have decided on your answer, then see whether that's true or not. SD, there you go.
Oh,
Right.
I was wrong.
Also. Now let me tell you something about percent, okay? Let me tell you something about percent. Percent is so easy to understand in the basic form. It's percent, right? Percent. It simply means per 100.
Okay.
So when I say 20%, there are many meanings to it, but the most basic meaning is 20 per 100. I mean, I
Okay.
told you that percent is fraction. For that particular reason, this symbol simply means over 100. 20 over 100, which of course for decimal is 0.2. That is the most basic meaning of percent per 100. So 1.2% gotta make you gotta confuse you just now, but it simply means 1.2 over 100. Then you just have to decide what kind of decimal would that be. Okay. Now I understand that you're not comfortable here. I want you to practice a little bit by yourself. Meaning to say, you're gonna type a random number in your calculator, percent. You're gonna make a guess in your mind, and you're gonna press the SD button. You're gonna do that now. Okay, please show it to me. All right, so let's get comfortable with the base. And the lights are off for you. Oh, there you go. Okay, there you go. Okay, so you decide on your own random number, please.
Okay. Can be any percentage, right?
Any, as long as it's a random number, and then you think first before you press. Okay, Ria, is this liquid or aqueous? You gotta decide. Okay, now, Jason, you don't have to wait for me, right? You just think and then see what happens. Are you correct?
Yep.
Okay, yes, it is. Okay, continue for a few more, Jason, a few more until you are at least okay lah with this. What do you think, Ria? You got this? Is the equals one? Sure thing. Okay, this is the equals one, and it's totally fine. That's equals. Okay, good. Now you gotta decide one more, which is the pure or the liquid one. Okay, you can do it first. Totally fine. Good. Yeah, now you're listing the you're listing the competitors. Very good. Okay, Jason is now dark. So okay, all right. Okay. Okay, that looks very complicated for a percent, yeah? That's fine. Okay, test yourself, right? Test yourself. Okay, looks complicated. Okay, good, good. You decide in your mind and you test. The competitors are there. Good, Ria, good. Okay, did you get it right, Jason?
Yep.
All right, cool, cool, cool. Try maybe two more. Try two more just to be sure, all right? After you try a smaller number, which is a very good practice, try a bigger number. See whether it confuses you or not. Like something big like 103% or 150%. I don't know. Try something like that. Okay, Ria, you decided that H plus will win. All right. Okay, I'm all for that. Right, Jason, how is it? Got it right?
Yeah, I got it.
Okay, good, good, good. You want to practice one more? So it's up to you, up to you. You decide.
Yeah, I think I got it already.
Okay, good, good. So that's the most basic meaning of percent. There are other things lah to consider, but this one is the easiest one. Really, the easiest one. So that's why when I show you it's 1.26 over 658, you are not experiencing from decimal to percent. The question is, can you go from decimal to percent? Just now you're going from percent to decimal. You should be able to go the other way. You're gonna type for me a decimal. Okay, let's say it's 0.65, and that's decimal, not percent. Now, in terms of percent, how many percent is this? Do you know how to do it?
Times 100.
Yes, you are correct. Try times 100. So, I mean, times 100 is simple, right? Times 100. And then the percent will not show. Go ahead. It's going to be 65, right? But in your mind, you must understand that this is times 100 means 65%, no? So 0.65 is 65%. So back to the question, 0.191 is 19.1%. Make sense? Huh?
Yeah.
All right. Now you know decimal and percent is a very straightforward relationship.
Yeah.
You can think of it as conversion. It is conversion. It is that's true. It is conversion. Nothing particularly difficult. Can you? Okay, good. We achieved something. We achieved something. Oh, we have 2 minutes left, Jason. We are still surveying our stuff. You can start the pattern or whatever. I want to see your comfort zone also. Is it really that bad? Something like that. Okay, just give it a try. Ooh, I like it very much. Ria, I like it very, very much. Very, very much. And you plus. Oh, what is this? Right. I like it. Oh, no. Okay. I like it. Come on, Ria, before time is up, decide a pure liquid ionic electrolyte. Okay. Do your correction.
Can HCl be a liquid?
I'm so sorry, Ria. What is it? Can
HCl be a liquid?
pure liquid. Okay, for now, theoretically, I have no idea. It's a very dangerous thing. Theoretically, pure HCl is a very dangerous thing. Okay. I'm sorry, I'll answer you practically. Yeah. So HCl, even though it's pure, will immediately absorb the water moisture from the surrounding air, and will do all sorts of other weird things which are very dangerous. Okay, let's pretend that is impossible. In reality, it's very impractical to do it. Instead of impossible, it's very impractical. Okay, it's more practicality. Maybe decide something else. In fact, your NABR can be liquid one. Cannot make? Can what? You can say NABR equals NABR liquid. Can. No problem. Okay, Jason, can you at least do one pattern, at least one part of the pattern, at least one before we close? Area, you cannot use equal sign. Okay, that's still a bad habit. Cannot. Good. Nice. Jason, are you in the pattern question or are you still thinking? It's okay if you're thinking.
Still thinking.
Okay. But I want to see a bit of the pattern question, yeah? Just a bit. Okay, Ria, looks good. The times 2, yeah. Very good. This is great. Ria, wonderful. Any questions? Oh, you didn't correct this. This is supposed to be plus. It's supposed to be plus. This thing. I'm not sure what you were writing. I thought you were writing minus.
Oh.
That's why I kind of circled it. But if it was a plus, I'm sorry. That means you're correct lah. That means you're correct. Okay.
Okay.
Okay. Ria, how do you feel about these two scenarios so far?
More confident.
More confident. And I can sense that definitely you're doing it faster. You're no longer making certain mistakes. You're doing it very well. Okay. I like it. That means next time, I don't think your school would have caught up to this. I don't think so. We will continue to the final scenario, like the 3 and 4 participant one. Okay, that's the most complicated scenario you have to consider. With this amount of foundation, I think you're going to be quite okay. Then we can immediately see what exam level question looks like.
Okay.
Okay, Ria? Okay.
That's
Very happy that the first time today I see you make your own question. That is very good. Really very good. I will ask you to make your own question. I ask all my students to make their own question from time to time because that is a very helpful practice, so to speak. Okay, very happy with you. And if there is nothing else, I will see you on next Tuesday.
Okay. Thank you.
Bye, Ria.
Bye.
You're saying that the answer should be 21, right? That's what you're saying. One. Again, let me convert. 21 is number of circles. So this, you're saying this is 21. Am I correct, Jason? That's what you're saying, right?
Yeah.
Okay. I mean, it looks about right? The pattern is plus 4, plus 4. Okay. Sorry, Jason, I want to confirm one thing. What you're doing is obviously correct, but do you see it as 1 plus 4, or do you see it as something like this? This is a method of saying plus 4, no? Plus 4, plus 4. So this must also be plus 4. That's just another way of seeing it. Okay, how do you see it? The 1 plus 4, or the every time is plus 4?
Every time plus 4. Yeah.
All right, then you should know that it's 17 plus 4 is also a useful way of doing it, right?
Yeah.
Okay, never mind A first. The expression in terms of N, I'm not interested right now. I want to know how comfortable you are lah. Okay. Can you answer D immediately? Can you do that using your own logic?
-1 and then divide by 4. That's what I would do.
-1 divided by 4.
Yeah.
Okay, try. And then what's your conclusion? Right. Try.
It becomes a fraction.
And your conclusion, therefore, is?
Wrong. Oh.
As in, there won't be a pattern with
there won't be a
shaded circle.
pattern.
And I agree with you. I agree. So, how many circle should it be, Lee? I'm expanding the question. If 178 is wrong, what should it be? You can test using a calculator.
Yeah.
Use your calculator, use your logic.
Yeah. I think it should be like an odd number now.
Show me. And they did tell you that it's always odd, right? So,
Yeah.
that's kind of like a hint lah. Nice to know, right? Let's use that.
177 because it's
Okay,
odd.
177. Yeah, I agree with you. 177 is minus 1 divided by 4 is a integer, correct?
Yeah.
Correct or not? 177. It can also be 181, either 177 or 181.
Mm.
Hey, wait, 181 is correct. Yeah, it's good. Yeah, good, good. Okay, good to know that you are comfortable with your logic in terms of pattern. We will just talk about the end next time.
Okay.
Okay, not so bad. All right.
Yeah.
So Jason, today we are doing a survey of questions for giving you an idea what end of year have in store. Yeah. Let's continue next time.
All right.
Good job, Jason, for the WhatsApp, for the WA, and I
Yep.
will see you.
See.
Bye.
Bye.